there's this very specific type of frustration, I think. You sit down at your computer, you ask an AI a question, and it gives you this brilliant, incredibly nuanced, expert-level response. You feel like you have superpowers.
Right. Yeah, like you've hacked the system.
Exactly.
Yeah.
But then, like the very next day, you sit down, ask what feels like the exact same type of question, and you get generic, unhelpful, almost robotic garbage. It is maddening.
It really is. It feels like the machine is just, deciding to be uncooperative on any given Tuesday. But looking at the underlying mechanics, the capability of the model hasn't degraded overnight.
Right.
The neural network's parameters are identical to what they were the day before. I mean, the only variable that actually shifted was the specific digital environment we placed it in.
And so that environmental shift is the entire focus of today's deep dive. We're unpacking a stack of research papers, some system architecture notes, and specifically an instructional framework titled Mastering Context, How AI Transforms Construction Data.
Which is a really fascinating paper.
It is. And our mission here is to uncover the actual underlying science of getting AI right. Because we need to stop treating these tools like, I don't know, a magic 8-ball and start treating them like what they functionally are, which is incredibly sophisticated,
right,
highly contextual autocomplete engines.
Setting the stage here is crucial, actually, because our source material uses the high-stakes world of commercial construction as its backdrop to explain these concepts. But we aren't just talking to construction managers today.
No.
The lessons we are extracting regarding context engineering, they apply to absolutely any field you might be working in, whether you are analyzing case law, diagnosing medical symptoms, planning a marketing campaign, or just organizing your personal research. The mechanics of how a human properly communicates with a large language model are completely universal.
Yeah, and to frame this whole conversation, I want you, the listener, to imagine that you have just hired a brilliant, world-class intern.
I love this analogy.
Right, because they've read every book ever published, they speak every language fluently, and they possess infinite computational capability. But unfortunately, this intern suffers from total, severe, short-term memory loss every single time they go to sleep. Every morning they walk into the office, they have absolutely no idea who you are, what company they work for, or what project they were doing yesterday.
That is exactly it. That analogy perfectly illustrates the architectural reality of how a large language model operates. We refer to this as the blank slate reality. These systems are inherently stateless.
Meaning that when you open a new tab on your browser to start a chat, that intern has basically just woken up from their amnesia.
Precisely. Standard LLM sessions have zero cross-conversation memory by default. Like the moment you close a browser tab, the mathematical state of that conversation is wiped from the server's active memory, completely gone.
Wow.
So when you open a new tab, the neural network starts completely uncolored by anything you did 5 minutes ago. Context is the singular bridge connecting the AI's vast, generalized training data to your highly specific world.
So let's define what context actually is in this framework, because I suspect most people, I know I did, assume it just means the prompt, like the literal text box where you type your question.
It encompasses far more than just the immediate prompt. Context is, well, it's the entirety of the data the model can mathematically see and process when it is generating the next word in its sequence.
Okay, so what else is in there?
That includes the system prompt hidden in the background, the entire chronological conversation history up to that exact moment, any documents or data tables you have pasted or attached, and your current question. If you do not actively curate that entire landscape, you are leaving the AI completely untethered from your reality.
Right, and the source material provides a highly specific example from the construction industry that grounds this perfectly. Because when you open a chat, the AI doesn't magically know that your job title is contract administrator. It doesn't know you are working on a massive BHP resources project.
Right, it has no clue.
Exactly. It certainly doesn't know you are operating under a specific legal framework like an AS4000 contract. And it has zero idea that you are dealing with a site superintendent who is notoriously slow at responding to requests for information, or RFIs.
And connecting that lack of specific grounding to your earlier frustration explains the robotic outputs you get. If you just open a blank chat and write an email asking for an update on the site issue, the AI is forced into a corner.
It has a guess.
Yeah, it has to calculate the most statistically safe response across all possible industries and scenarios. So it defaults to the most average, middle-of-the-road corporate speak because it cannot risk making an assumption about your contractual stakes. I mean, it doesn't know if a late response means a mild annoyance or $1 million legal penalty.
So you have to explicitly define those stakes every single time, which leads to the core maxim we pulled from the framework. No context equals generic answers. Rich context equals expert answers. But let me push back on this for a second, though, because I think a lot of people listening might be skeptical. When I get a highly generic answer to a specific question, is it really just a lack of context? It's tempting to think the AI just isn't smart enough to handle the complex, nuanced reality of my specific job.
It is a very common misconception to confuse a generic output with a lack of reasoning capability. The reasoning ability, the semantic understanding of complex legal or technical frameworks, all of those weights and connections actually exist within the model's parameters.
Okay, so it has the brains.
Right. But the parameters need specific variables to operate on. Think of it like a brilliant chess grandmaster. You are asking them for the best possible next move, but you are refusing to show them the board.
Oh, that makes sense.
They possess the capability to analyze the board, but without the context of where your specific pieces are positioned, they can only offer you generalized platitudes about chess strategy.
They'd say something like, control the center of the board and develop your knights, which is objectively true but completely useless if I am about to be checkmated in 2 moves on the side of the board.
Exactly. So the paradigm shifts. The goal isn't searching for a smarter AI. The goal is mastering how to properly populate the blank slate of the model you already have.
And looking at the instructional framework from our sources, they present a structural solution for populating that slate without making a chaotic mess. They call it the 3-layer cake of context, because clearly just throwing random facts at the AI isn't going to yield that expert-level response.
The sources reveal that structuring this context is what truly separates novices from power users. Most casual users only ever provide layer 3, which is just the immediate action they want.
Just the command do, right?
Right. The power users, the ones extracting transformative, highly accurate results, consistently stack all 3 layers to build a complete operating environment for the AI.
Let's pull those layers apart. Starting with layer 1, the framework labels this system context. This seems to be purely about defining identity and overarching purpose.
Yeah, so you are giving that amnesiac intern their professional identity. Drawing from the construction source example, instead of just dropping a question into the chat, you begin by establishing a persona. You are an expert contract administrator operating under Australian construction law.
And mechanically, by doing that, you are actively pruning the AI's search space. You are telling it to prioritize its internal parameters related to Australian law and basically ignore general global contract law or irrelevant industries.
That is the exact computational effect. You are shifting the probability matrix of the words it will generate next. Then you build on that with layer 2, which is project context.
Okay.
This defines the specific environment, the rules of engagement, and the key players involved. In the construction scenario, you explicitly state, the contract we are operating under is AS 4000-1997. We are the contractor, and the principal client is BHP.
So now the AI understands its professional identity, and it understands the strict boundaries of the environment it is operating within. It knows the specific legal clauses it is bound by.
Yes. And only after establishing those 2 foundational layers do you introduce layer 3, the task context. This is the immediate granular action required at this exact moment. The source example instructs, draft a backcharge notice for this specific defect.
I find it helpful to visualize this like directing a movie. Layer 1 is casting the actor in a specific role, telling them, you are a gritty 1920s detective.
Oh, I like that.
Yeah, and layer 2 is constructing the physical set around them. So you are standing in a rainy alleyway in Chicago, and the local mafia is actively hunting you. And layer 3 is finally handing them the script for the scene. Now, interrogate this witness. If you just shove a script into an actor's hands without telling them who they are playing or the stakes of the environment they're standing in, the resulting performance is guaranteed to be incredibly flat and unconvincing.
The output transforms entirely when you stack the role, the environment, and the task. The model stops generating responses based on the mathematical average of the entire internet and begins generating responses based on the highly specific intersection of Australian law, the AS 4000 contract, and your specific defect issue. It sounds like a seasoned colleague.
Hearing this, the natural inclination for a user, and I have definitely fallen into this trap, is to think, well, If stacking context is the secret to expert answers, I should just give the AI absolutely everything.
Oh, yes, the data dump.
Exactly. I will paste in the entire 200-page contract, I'll upload the whole project history, and I'll drop in every email I've received this month. But the sources flag this as a massive, counterproductive trap.
It is the trap of overcontextualizing, and it stems from a misunderstanding of how an LLM processes data. It comes down to understanding the context window budget.
Let's dig into the mechanics of that budget, because it's not just a file storage limit, is it?
It is not. Every AI model has a finite context window measured in what we call tokens, which are essentially chunks of words or characters. This window is the absolute limit of what the neural network can hold in its active processing memory at one time.
Right.
And the critical detail people overlook is that absolutely everything competes for space within that finite budget. Your initial instructions, the pasted documents, the ongoing back-and-forth conversation history, and crucially, the model's own previous lengthy answers are all eating into that token budget.
It's prime computational real estate, and it fills up way faster than you realize.
Exactly. The source material highlights that wasting this budget on irrelevant material is a leading cause of AI hallucinations and degraded performance. For instance, if you need the AI to analyze a highly specific issue regarding, say, Clause 35.2 in your contract, you should actively avoid pasting the entire 200-page document into the chat. You must extract just the relevant section and provide that.
But I can hear the listener pushing back on this, though. Because the entire selling point of these enterprise AI tools is that they act as supercomputers, right? They can ingest a 200-page PDF in 3 seconds. Why should I spend my valuable time scrolling through a dense document to manually extract Clause 35.2? Shouldn't the machine be doing that heavy lifting?
That intuition is incredibly common, but it fundamentally mischaracterizes how the technology works. Yes, the AI can technically read or tokenize 200 pages in seconds, but processing speed is not the bottleneck. Mathematical attention is the bottleneck.
Attention meaning the way the model weighs the importance of different words against each other.
Exactly that. Under the hood, these models use an attention mechanism to determine which tokens are most relevant to generating the next word. When you force the AI to tokenize a 200-page document to find a single clause, you are forcing the attention mechanism to calculate the mathematical relevance of millions of useless tokens. You are essentially hiding the signal in a massive field of noise.
So it isn't about the AI being too slow to read it. It's about diluting the AI's focus.
It is the quality versus quantity rule of context engineering. More context is not inherently better if it isn't strictly relevant. Adding noise actively dilutes the model's attention weights, which directly degrades the sharpness of the output.
That makes a lot of sense.
The sources use a fantastic example of drafting a variation claim, which is a formal request for more time or money on a construction project. If you are tasking the AI to draft this claim, you absolutely should include the highly relevant contract clauses, the specific disputed RFI log, and the detailed scope description. Those items represent high-value signal.
Because those are the specific mathematical variables it needs to construct the logical argument.
But you must actively exclude the 500-page general project specification, the unrelated email chains complaining about, like, site parking, and the general contract conditions that have no bearing on this specific claim.
Right, because if you include all that garbage, the AI is holding the site parking emails in its active working memory, calculating their potential relevance, while it's trying to draft a highly technical legal claim.
Context acts as a signal to guide the neural network. Extraneous information acts as noise that degrades that signal. The overarching lesson from the framework is to act with surgical precision. Hyper-relevant context beats maximum context, without exception.
That makes perfect mechanical sense. We curate the 3 layers, system, project, task, and we do it surgically to preserve the attention mechanism. But I have to admit, looking at this practically, if I am required to type out, you are an expert contract administrator under Australian construction law operating under AS 4000 1997 on the BHP project. If I have to type that every single time I open a new tab, that introduces a massive amount of friction. It feels like I'm wasting time setting up the tool rather than doing the work.
Oh, absolutely. But the sources address that exact bottleneck by introducing what they consider the ultimate efficiency hack for power users, understanding the distinction between session context and persistent context.
So decoupling the daily workflow from that tedious setup phase.
Exactly. Up to this point, we have entirely been discussing session context. As we established, this context is transient. It lives only as long as the browser tab is open, and it dies the moment you close it. Persistent context, however, is an architectural environment you build once, which then automatically carries forward into every future interaction.
How does that actually manifest in the tools people use every day?
Well, depending on the specific platform you subscribe to, this feature might be labeled custom instructions, a custom GPT, or a Claude project. The underlying mechanism is identical across all of them. Establishing this is the highest leverage investment a professional can make when adopting AI. You create a persistent background profile.
And what goes in there?
Into this profile, you load your specific company background, the standard contract frameworks you utilize, like that AS4000 standard, the key stakeholders you frequently interact with, and your strict formatting preferences.
Oh, so you can dictate structural rules, like telling the model. Always structure responses in highly scannable bullet points, and permanently ban the use of overly dramatic AI words like delve or tapestry.
Yes, you lock all of those parameters into the persistent layer. Mechanically, what happens is that the platform invisibly prepends this rich context to every single new chat you initiate. Every time you open a tab, the AI begins the session already deeply grounded in your professional reality. You have effectively automated layer 1, the system context, and layer 2, the project context.
The amnesiac intern walks into the office, but somebody has already handed them a comprehensive dossier on who they are, who the clients are, and what the rules of the building are before you even say good morning.
Because layers 1 and 2 are permanently locked into the model's baseline attention weights for that workspace, you, the user, are now only responsible for providing layer 3. You just open a chat, drop in a specific defect report, and type draft the backcharge notice. The model already possesses the context of how to format it, what tone to strike, and which legal framework governs the language. The reduction in repetitive token generation and user friction is massive.
Let me ground this in a final visual. If session context is like painstakingly drawing a complex, beautifully detailed graph on an office whiteboard, only to have the night cleaning crew wipe it completely blank every single evening, persistent context is taking a permanent marker and etching the axes, the labels, and the grid lines directly into the whiteboard. So every morning when you walk in, you aren't redrawing the foundational structure, you're simply plotting today's new data points.
That perfectly encapsulates the shift in workflow. By mastering persistent context, you transition from constantly having to educate the AI from scratch to actually collaborating with a customized digital asset.
We have dissected a significant amount of underlying mechanics today. Let's distill this entire framework down to the 3 actionable rules extracted from our sources. Whether you are managing commercial construction or organizing legal research, these are the principles you need to apply to your daily workflow. Rule number 1. No context yields generic answers. Rich context yields expert answers. If the output you receive is robotic or unhelpful, don't immediately assume the model lacks intelligence. Look first at the lack of specific reality you provided in the prompt.
That's rule 1.
Rule number 2. Relevant context always beats maximum context. Resist the urge to dump your entire hard drive into the chat box.
Please resist it.
And rule number 3. Context is a mathematical signal, and extraneous noise directly degrades the model's attention. Be surgical. Curate exactly what the AI needs to process the specific task and actively exclude everything else.
By internalizing those mechanics and shifting your workflow to utilize persistent context, you fundamentally change your operational relationship with the technology. You stop fighting the machine's limitations and start leveraging its architecture.
Because mastering the AI's context window isn't just a neat trick, it is the master key to unlocking the actual utility of these systems. Context engineering is the skill that separates the casual user from the professional.
Though, analyzing this from a slightly broader perspective, successfully engineering that context introduces a rather profound operational question.
Oh, I always appreciate a pivot into the profound. Where does this leave us?
Well, we have dedicated this deep dive to the mechanics of building a persistent context so that the AI perfectly internalizes your specific rules, your unique environment, and your exact operational preferences. You are, in a very real sense, mathematically cloning your own professional paradigm into the machine's weights. But if you successfully engineer an AI to analyze data exactly like your most expert employee, operating flawlessly within the boundaries of your specific worldview, How does that alter the way you value your own human intuition when the AI inevitably disagrees with your assessment?
Oh, wow. That is a deeply uncomfortable tension to navigate.
If you have meticulously trained the system to know everything you know, and it analyzes the contract data and objectively calculates that the optimal path is to go left, but your human gut instinct insists you must go right, who holds the ultimate authority?
We dedicate all this effort to making the intern brilliant, but we desperately want to retain our status as the boss. And when the intern, with the perfect computationally sound memory, tells the boss that their intuition is statistically incorrect, that is an entirely new kind of workplace friction. It's a fascinating tension to leave you with as you head back to your own context windows. Thank you for joining us on this deep dive, and we will catch you on the next one.